So going back to the 2015 test, this is a type 7 question. Doesn't really fall in any category, so you're going to see very random stuff in type 7. Writing an equation line is basic calculus. That's where we started our year from, and our function that we started our year with, we'd say a function can be approximated by the line, which is f of the center plus f prime of the center times x minus the center. So that's where we started our year. This is the y coordinate, and they give us the y coordinate. They're saying find the tangent line at negative 1, 1. So our y coordinate is 1, and the x coordinate is negative 1. And the only calculation that we need to do is compute our slope. So a quick computation of the slope, you're calculating your slope at the coordinate negative 1, comma 1, which means you're sticking negative 1 in for x and 1 in for y. And if you do that, you would get 1 over 3, 1 squared minus negative 1, which equals 1/4. And that's the number that goes in for our slope, 1/4. Most people would combine the two negatives here to make it a positive, so subtract negative becomes plus. This is worth 2 points. 1 point for correctly computing the slope, and then 1 point for having the correct line equation. So 1 and 1. All right, let's move on to part B then. Find all the coordinates of all points on the curve at which the line tangent to the curve is vertical. So vertical tangent lines occur when the denominator of your slope is equal to 0. It's kind of like saying when you have a non-zero number on top and a 0 number on the bottom. That's what causes a vertical tangent line. So in order to have a vertical tangent line, 3y squared minus x must be equal to 0. Now this is a two-variable equation, so it's not solvable until you introduce a second equation that relates x and y. And they give us an equation to start off with of the implicitly defined curve, which is an equation in x and y. So if we take that equation, y cubed minus xy equals 2, and we make a substitution of a known relationship, we're going to reduce our equation to a single variable equation. So y cubed minus 3y squared times y equals 2. Yeah, it is a lot of algebra for a calculus test. Y cubed minus 3y cubed equals 2. Negative 2y cubed equals 2. Y cubed equals negative 1. And we get the coordinate y is equal to negative 1. Now that's just the y part of the coordinate, so we also have to figure out what the x coordinate is. Well, that's going back to our relationship between x and y. So at the point 3, comma, negative 1. Okay? And there is one last thing we should check. We should make sure that this point doesn't cause a 0 in the numerator. And if we look at our slope, sticking negative 1 into the numerator, we don't get a 0. So we have the case of non-zero over 0. Vertical tangent line at the point 3, comma, negative 1. This is worth 3 points. The first point comes from recognizing that the denominator of our slope must be 0 for a vertical tangent line. Your second point comes from creating an equation that is in a single variable. And then your third point comes from having the answer at the end. The only bit of calculus was this recognition that a vertical tangent line occurs when the denominator of a dy dx is equal to 0. The rest of it was algebra. As a quick reminder, this 3 came from plugging -1 into this equation. 3 times -1 squared is 3. So that's how you get the exponent. Part C. Evaluate the second derivative at the point -1, 1. This means we're going to need to find the derivative of the derivative. So I'll just go ahead and write the first derivative down. We are going to need to take the derivative of this, and because this is a quotient, we have to use the quotient rule. So the derivative of the left, and now the derivative of the right. So numerator primed is dy dx times the denominator. Subtract the denominator primed, which is 6y dy dx minus 1 times the numerator, all over the denominator squared. So that's the use of the quotient rule. F prime g minus g prime f all over g squared. We can substitute in our dy dx right here, or we can go ahead and start evaluating this at -1, 1. Because I already know what is dy dx at -1, 1 from part A, we know this value to be 1/4. I'm going to bypass that substitution and just stick 1/4 in there. 3 times 1 squared minus -1. Subtract 6 times -1 times 1/4 minus 1 times 1 all over 3 times 1 squared minus -1 squared. There is a lot of arithmetic simplifying that you can do to this. But remember, this is a numeric answer, and provided that I didn't make any mistakes substituting numbers, this would work. This counts as a correct answer. For the people who do go through the process of simplifying this, it reduces down to 1 subtract a half over 16, or 1/32. 4 points. You get 2 points if you do implicit differentiation. So 2 points for doing the implicit differentiation. Then you get 1 point for substituting in the dy dx, and I believe that they would give me credit for putting in the 1/4 right there as that substitution. And then your last point comes from, do you have the correct numeric answer? Now, if you didn't have a point, a xy coordinate pair to plug in, you would instead plug in y over 3y squared minus x into that slot. All right, be sure to comment, like, subscribe. Hit that bell for notifications. Smash the like button. Ask good questions, conquer the world.